Thank you. And Christina, as someone who studied with Dr. Zhu, I got to tell you, he's a very serious scientist, and I, for one, am not surprised that we won that award. Today I'm here to talk about sorry for this remote connection thing. But while she's doing that, basically, these systems that we're developing at the center for on-site wastewater treatment, our target is we want them to be robust and cost-effective. But everything that the center does is local. So we use local materials and we use local labor. That means jobs for Long Island. And all of our products are non-equipment intensive and non-energy intensive. So if you look back in the mid-century, there were 200,000 people in Suffolk County, and there were 6 million ducks, together delivering about just over 3 million pounds of nitrogen per year. And now there are 1.5 million people that alone are delivering about 50 million pounds of nitrogen a year, and there's one duck farm left. And of course, there's agriculture and synthetic fertilizers as well. That's increased over that period. But it's not just a matter of quantity of increase in nitrogen. It's the way it's being delivered. So duck farms are all pretty close to rivers or estuaries. And then agriculture, some of that nitrogen is taken up plants, some of it is volatilized into the air, and some of it percolates down into the drinking water aquifers. But with people, it's direct injection method through cesspools directly into our drinking water. And you can see the bottom chart on the lower left, about half of the water that's the nitrogen that's reaching the watersheds is from the cesspool. Over on the right, it shows some of the 30-year period in 2017 that dramatic increases in the nitrogen or nitrate concentrations in our upper glacial on the top and magnetite aquifers, which doubled over that period. The thing is that those are averages. There are places, if you read the Suffolk County Subwater Sheds plan, there are places that are getting 10 milligrams of nitrogen in water. Why is this important? 10 milligrams happens to be the EPA limit. But there have been a number, Chris and I were having a conversation about the other day, we thought 20 articles in the last 2 decades of epidemiological studies that correlate drinking water nitrate and serious illnesses like premature birth, like colorectal cancers and other cancers. But the important thing is this is at 3 milligrams per liter, not 10. And I'm sure just about everybody in this room also knows that when that nitrogen discharges, or that groundwater, nitrogen-rich groundwater discharges into lakes and estuaries, marine systems, that there's a cascade of environmental problems. So nitrate fertilizes the estuaries and the lakes, resulting in turbid water column, which leads to a loss of light and loss of benthic plants, which provide nurseries for the ecosystem there, and that leads to a crash in biodiversity. Algal blooms strip the water of nitrogen into fish gills, and fish are facing the wrong way because they're dead. And harmful algal blooms, which Chris has studied over the last decades. So cesspools do not remove nitrogen. What is needed is robust systems that achieve low nitrogen concentrations at reasonable cost and without high maintenance requirements. At the center, All of our technologies revolve around the basic principle, which is coupled nitrification, denitrification. Now, this occurs naturally in the environment. It occurs in sediments of coastal, of continental shelves, estuaries, it occurs in soils and forests. But basically, it's the coupling of oxidized form of nitrogen, which is nitrate, which is then denitrified into basically air, into dinitrogen gas. And so our systems just speed that up in a process happening. So we deliver wastewater through a distribution system over underlined 18 inches of sand, which oxidizes the reduced forms of nitrogen into nitrate, and then in a anoxic layer, it's denitrified into air. And there are these basically three designs that we use. This one is the unlined NRB, and that one is direct final discharge into groundwater. Again, it works with a septic tank that is pumped into the drain field, 18 inches of sand, 18 inches of sand and wood chips. It's unlined, and so wood chips in this configuration are subject to cycles of wet and less wet. And that system, the wood chips aren't thoroughly anoxic all the time. That one, we actually target final effluent in nitrate about 15 milligrams per liter. Second system attempts to address this problem by putting a liner around the system and running a pipe from the bottom of the system. So wastewater is channeled up to through that pipe up to the interface between the sand and wood chips, and that creates a hydraulic head so that the wood chips remain continuously saturated and therefore anoxic, and that allows better denitrification. And the third design takes the sand portion, that is the nitrification oxidizing portion, and channels the water down into a wood chip box. In that box, there's much greater volume of wood chips and much greater surface area of wood chips, so that it really enhances the denitrification. And both of those second systems aim for 10 milligrams of nitrogen. How have they been doing? Well, to assess that, we decided just to fast forward the tests for these systems, the Article 19 tests, and assume that as the data at the end of last month, that they were the test to decide whether they go from a pilot phase to a provisional acceptance was right. And so what you can see is that the unlined systems get about 15.4. 5 out of 8 of those systems are getting better than 19 milligrams per liter. The second system, our line system right now, averages 7.5. I expect that to drift up a little bit in the next few months. That's pretty good right now. 6 out of 8 of those are getting better than 19. And then the wood chip box systems are getting 14. Now, that TN in final effluent is higher than line, but it's because those three systems happen to have very high levels of nitrogen in the effluent. So they're reducing 87%, but those numbers are about 120 to 135 total nitrogen in the influent. So they're reducing just about all of that. And the other two are somewhat less efficient, but still, if you handle up to about 100 for the line. And we have one unlined system that has been for over 40 years getting less than, we're getting about 14 and its influent concentration is 90 milligrams per liter. But on average, I would expect it to get 60 to 80 in that range. So how do they compare against commercial systems? They're okay. They've done they reduce nitrogen pretty well. So, but on-site wastewater contains more than nitrogen. So it contains emerging contaminants. Our drinking water team here at the center did a study over a year ago where we looked at how these systems remove the dioxide. And they reduce it by about, in some cases, up to 8 times, down to the less than the New York drinking water standard of 1 ppb. Also, another student here, Dr. Tricia Klein, has since graduated, looked at a suite of pharmaceuticals and personal care products that are typical of on-site wastewater, and found reductions of 50 to 100%. We also, in Dr. Shinwei Ma's lab, they looked at phosphorus in the last year in the effluent of these systems. And you can see that there's pretty significant removal. Now, for both the PVCPs and phosphorus, this isn't, these systems have been running for, as you can see from the chart on the left, in some cases 3 years or more. So it's not absorption into new soil that is taking out that phosphorus that's organic compounds by ionic reactions. It's biological or abiotic reaction that's removing. So we, as I alluded to earlier, are in the pilot phase for the NRBs, and we have 8 of them that are now being tested for provisional. If everything goes right, we anticipate provisional acceptance in first quarter next year. Same thing for the line, and we need to install 3 more woodchip boxes to start the testing for provisional. Going to provisional means that we will operate differently. Previously, in order to do installations, the center initiated them and we went out and got grants, water quality grants, federal grants to do that. But in the provisional phase, that would be a commercial transaction, hopefully with SIP grants for the homeowner. The homeowner will initiate the transaction. So that's a big change. I can't address the entire change here, but I'd like to bring up a couple of points. So one question that we often get from homeowners and prospective purchasers of these systems, installers of these systems, is carbon longevity. Also the footprint, the cost of the system, and the installation time. So I'll address those. So some of the first people who installed these systems back in the 90s, these woodchip biofilters, well, in Waterloo in Canada, and those systems they put in the mid-90s, those systems are still removing nitrogen. And we have a system, an unlined system prototype up at Massachusetts Alternate Septic System Test Center, which has been running for about 6 years. We did all kinds of tests on it, cranked up loading rates, and because of that, its performance began to deteriorate from under 10 to about 14, 15. And we decided, okay, well, we're going to excavate it and take a look at a lot of things. And we're hoping to get some papers out of that work. We process that. And but we put soil and wood chips from that into 2 different treatments. One, barrels that were unsaturated, just dosing and the water drained right out, and barrels that were saturated. What we found was that wood chips worked even better than when we started in the saturated, but they didn't in the unsaturated. So this points to that wood chips are fine, they last, that's not an issue. Thing is, this one system had been subject to these higher loading than it should have. We did that as an experiment, and that can compromise the system and lead to air intrusion and oxygen intrusion. That you can't do. So footprint. This is a system on an unlined NRB on a half-acre lot. There's a house in your driveway, 600 square foot of a drain field. And this is a picture of one of them. You can see that it doesn't affect the lawn at all. You do need to put some posts or maybe some rocks to keep tree cutters or heavy equipment off of that. But anyway, that 600 square foot, that's 3.5% of that half acre plot. It's not that much. Of course, you can save space if you need to by putting in an IA with just one leaching pool. But as you get that is if you have depth of groundwater of greater than 17 feet. The NRB, the unlined NRB, only takes 7 to 8 feet. If you start to get to lower, more shallow groundwater, then you have to put in systems that take up more space. So, for instance, an IA system with 3 leaching galleys for groundwater depth less than 9 feet takes up about 140. And if you have to put in a groundless and sorption bed, that's almost as big as the line system. Costs. We think there's some gains. We put in some systems, and I think we can improve and lower the cost. We can do it without a pump chamber, putting a biotube directly into the septic, clarified part of the septic tank. We also think we can do a better job of woodchips and fill. Installation time. So an unlined system takes about, an IA system takes, as I'm told, about a day and a half, 2 days. An unlined NRB takes about 2 days to 2.5 days, and lined woodchip take longer because you've got to put in a liner and some final disposal. So this chart in the middle here, that's just a classic economics 101 efficiency. So your unit cost goes down the more units you produce. Calculators used to be expensive in the 1980s. Tesla's started out expensive and gotten cheaper. There's this principle about lowering unit costs and increasing your volume. And that's what I keep telling our installers. If they follow the path of Gordon Moore or Elon Musk, that they should consider that chart. So next steps for us, continued research on wood chips and materials that we can improve the unlined system performance a bit. Publish a guidance document in design installation training course, and work with installers to make NRBs a common IA septic solution. I want to mention one more idea here, because I don't want anything that I've said to make you think IAs aren't good. There are a lot of really good IAs out there, but they can be even better. Just about all of them have air rates, which means that they nitrify very well. And if you look at the composition of nitrogen in their final effluent, it is mostly nitrogen. So say an IA is doing very well, getting 12 milligrams per liter of nitrogen, it's final effluent. 10 of that might be nitrate, 2 of that would be organic form. Well, we have proved that woodchip boxes get 80 to 90% removal of nitrate. So if you attach a woodchip biofilter on the back end of an IA system, you can reduce that 10 down to say 1 or 2, and then you get total nitrogen final effluent of 3 or 4. So there's 2 models that we've come up with. One is a woodchip, just a woodchip box system, like the one attached to this sand filter. The other is PSD with wood chips. And the reason that we designed that is this. For the last 5 years, we've looked at several PSDs in Long Island, and they don't remove nitrogen. The idea of a PSD is it's a pressurized system that sits above natural soil. That natural soil is not removing nitrogen. Why? Probably because the perk rates here in Long Island are too high. So if you put sand and wood chips in there instead, you've got a really good chance of removing almost all of that nitrogen. So we have one of those that we just installed at the Center of Woodchip PSD. We have boxes installed in East Hampton, and these are a chart of the results. So in the upper left, you can see that the IA system is working like it's supposed to. That's between 3 and 12 milligrams of nitrate, and it's reduced. The nitrate is reduced to about 0 by the woodchip box. In the second case, this was a surprise. The IA system was not working so well, and that sometimes happens. Not every system works perfectly, but the woodchip box was able to reduce all the nitrate to about 0, so that that system still does very well and certainly satisfies the the RF19 requirements. So thank you very much for your attention. And with that, I'm going to turn this over to Xinwei Mao, who's going to discuss the next gen systems.